Thanks a lot, Graham, for that. And yes, so globally, there are about 2 billion domestic refrigeration freezers, 120 million pieces of commercial refrigeration equipment, lots of refrigerated vehicles, refrigerated containers, and cold stores. However, the capacity is distributed unevenly around the countries. As one example, while the average cold storage capacity in North America or Europe is around 200 cubic meters per 1,000 inhabitants, in the least developed countries, it's only around 20 cubic meters per 1,000 or even less. In Rwanda, only 5% of firms in the food and agri space have refrigerated trucks. For smaller marginal farmers, where the majority of post-harvest food loss occurs, functional cold chains are completely absent, less than about 1%. Why does this matter? So of the 6,300 million tons of food which we produce globally, 2,000 million tons require refrigeration processes, yet only about 400 million is preserved using refrigeration, chilled or frozen. And lack of effective refrigeration today is estimated to directly result in loss of about 13% of total food production, enough to feed about 950 million people in the world, whereas we know 690 million are hungry and 2 billion suffer from food insecurity. Moreover, the populations in most developing countries depend heavily on agriculture for their livelihoods, making development of cold chain a really key tool to boost incomes and foster economic growth. And at the same time, the production of food which doesn't make it to the market, accounts for 2 gigatons of CO2 emissions per annum. It also impacts the waste of natural resources, land and water. So in short, for me, food saved is as important as food produced. And in the coming decades, food cold chains are expected to expand significantly to cope with this increasing demand for perishable food products in a warming world, as well as address current unmet need for cold chains. But how do we achieve this sustainably within the limits of our planet? Cooling today accounts for about 7% of global greenhouse gas emissions, and cooling and refrigeration are the fastest growing sources of GHG emissions in the world. How we meet new cooling demand in a warming world will materially impact our ability to mitigate climate change and manage our natural resources, and also to absorb, recover from, and adapt to disturbances, whether they're natural or operational. And equally, as we've seen in recent months, food security is an integrated global issue. Here in the UK, we're reliant on imports, much of our fruit and around half of our vegetables. And with global food demand set to grow by 50% by 2050, driven primarily by people in the developing countries, shift towards urban living and more Western diets. And at the same time, we've got rising temperatures, the frequency, intensity of droughts and flooding. These are all impacting the food cycles and reducing the land and the availability of food. So there's going to be greater demand on our food and our food systems, which will impact availability and price. Cold chains, reducing food loss, protecting the delivery is going to become more and more important. But from my perspective, I think the key point is, or one of the key points is that cold chains aren't simply cold storage. Cold chains are complex, multi-dimensional systems that underpin the food system from the production through to the distribution and consumption, and include both static and mobile elements, which have to work seamlessly together, especially in this transition to renewables. Cold chains must also consider the packaging used and the other environmental parameters that affect the usable or saleable life of produce and products under care. The food industry has made significant efforts to reduce energy consumption already, whilst at the same time increasing levels of production. But traditional approaches to intervention have, in my view, been mainly reductionist, with piecemeal projects around individual cold chain technologies or interventions in silos. And optimizing the subsystems neglects the interdependencies between them and their relationship, especially with other local energy vectors, and result in a suboptimal system of systems. Optimizing the system also requires engagement and accountability at multiple levels, from the farmers, the processors, the manufacturers, the aggregators, the distributors, retailers, and consumer, all working together. And so an integrated transition to energy efficient, technology and economic optimized net zero cold chains is unlikely to emerge organically, given the many actors both in the UK and our global supply chains. And this, I think, can risk the UK's climate targets, our energy security and food security, as well as risk economic opportunity for our food growers, fishers and producers. So in short, developing a sustainable food cold chain is for me a wicked problem with diverse partners, drivers and barriers, all interconnected across the world, depending on the local economic, environmental, social, cultural and political circumstances. But acting on sustainable cold chain offers a real win for people, business and the planet. Cold Chain Federation has done some surveys of how it's can impact business. And you'll hear about these later on today. But you'll also hear today there are a number of barriers. It's not just technology. Issues include lack of cold chain market data, lack of infrastructure, critically lack of skills, particularly as we look to deploy new technologies and low GWP or natural refrigerants, lack of clarity on what to invest in, business models, lack of policy drivers and incentives. And so the way we think to support a sustainable cold chain is through coordination. And with experts from London South Bank University, Cranfield and Heriot, we've created a collaboration to work on this challenge at both UK, Europe and global levels. We've partners across Europe and into Africa and Asia. We currently lead or co-investigate in a series of programs looking at resilient and sustainable cold chains. These include, as Graham said, 2 programs in the UK looking at build the road to sustainable cold chain systems for food resilience out to 2050. The aim is to deliver a clear industry-led pathway to achieve the UK's net zero 2050 target while maintaining food security and affordability for consumers and economic opportunity for the UK food industry. We've a parallel project in Europe led by Sintef in Denmark with 27 research partners across Europe. Other programs include looking at the fast-track vaccine cold chain assessment and design for mass-scale COVID-19 vaccination using Bangladesh as the case study. And of course, the new Africa Centre of Excellence, which is looking at sustainable cooling and cold chain based in Rwanda, with an outreach program in Kenya and second centre being developed in India. All of these are multidisciplinary, bringing together expertise from the universities, the international stakeholders, multinational agencies, the government partners, and the industry. So in closing, the world is off track to meet the 1.5 degree objective of the Paris Agreement. We're also off track to meet the Sustainable Development Goals and adapt to fast increasing climate heat. Economic and social development and the environment have to live together. You can no longer have one at the expense of the other. Rather, our aim has to be a world where everyone can live well and with the sustainable limits of our planet. Cooling in a warming world, and in particular, how we protect our food and our medicines and vaccines, sits at the nexus of this challenge. Thank you very much. Back to you, Graham.
Fantastic, Toby. There was some brilliant stuff in there. I like the jail metaphor there, and yeah, it's very, very descriptive, very, very powerful, brilliant introduction. Thanks very much, and thanks very much for keeping to time. And the second speakers we have, it's a double act, and it's Natalia from Cranfield and Judith Evans from LSBU, and they're going to be introducing the 2 projects, SCC and ZECC. And just before we we ask them to start, just to repeat for everyone, if you've got any questions, so those that joined late, if you've got any questions, feel free to use the chat. It'd be great to start up some discussion and debate in the chat, and it's always difficult to be the first one, but you know, feel free to put something in there, start some discussion. And secondly, just reminding everyone this is being recorded, and that will be available on the UKERC website afterwards. Anyway, enough from me. Please, Judith and Natalia, over to you two.
Thanks, Graham. Hi, I'm Judith Evans from London South Bank University. Natalia and I are going to be talking about the 2 UK projects that we're working on cold chains. The first one is sustainable cold chains. And if my slides would move, great. So just in terms of a quick background, the food and drink industry is the largest manufacturing sector in the UK. And it's actually responsible for about 176 megatons of CO2 equivalent emissions. But that excludes the pre-farm production, packaging, food waste and land use change, which are also massive. One of the issues with the food industry worldwide, and particularly in the UK, is majority of companies are SMEs. Many of them are micro SMEs. And so that leads to some challenges in how we can get access to companies and work with them to reduce emissions. And the sort of high level figures are for food refrigeration. It's perhaps responsible for about 2 to 4% of the UK's global greenhouse gas emissions. But this is one of the things we're working on in the project, is to try and update those figures. So in terms of what Sustainable Cold Chain project is going to do, it involves ourselves at LSBU, University of Birmingham and Heriot University. And the idea is to produce some comprehensive evidence-driven set of roadmaps for the UK food cold chain. Let me just put my pointer options on these. Great. And so we're looking at really how the food cold chain in terms of refrigeration can achieve zero carbon emissions by 2050, whether it's possible and what they could do to get as close as possible to that as is possible. We're starting by benchmarking the existing cold chain, and that's what my colleague Alan Foster is going to talk about in one of the later presentations. So he'll present some of the information that we've got so far. So basically what we're looking at is we have some emissions against a time frame, and what we're looking at is we're creating a baseline for 2019, 2020, and we're looking at what happens if we don't really make many changes. It's basically business as usual. So basically we're just applying the changes that we know are going to happen, because we know obviously there are going to be some changes, for example, in climate. We know that the emissions conversion factor will change in the UK. So we're looking at basically business as usual. We're then looking at what we could do with current technologies, so relatively well-developed technologies that are ready there already. And if we applied those, what would happen? We're also then looking at what future technologies might be available. So things a little bit further down the road that we could apply to see what the impact would be. And then looking at what the difference is. You know, can we actually get close to zero? Or have we still got a gap which has got to be taken up by, you know, other things such as renewable, carbon capture, sequestration, etc. And the idea is ultimately to develop a pathway, or maybe several pathways, to a net zero food cold chain in 2050. In terms of our boundaries, because it's quite important that we're quite clear about what we're looking at. We're looking at harvest and slaughter to consumption. We're only looking at cooling related aspects, and that includes food and drink. We're looking at transport emissions, but only from refrigeration. And our emissions are within the UK border. So it's net food in the UK. At the moment, we're ignoring external to the UK. But as Toby mentioned, we do have a European project where we will be looking at emissions in Europe as well. And we're looking at energy. Most of the emissions, the indirect emissions from refrigeration, are energy related. And we're also looking at direct emissions, which are mainly refrigerant leakage when we're talking about the refrigerated cold chain. And so we're creating a baseline, and we're collecting as much information, or have actually collected as much information as we can, looking at what data is available. So we're looking at things like published high-level information, peer-reviewed publication, consumption, numbers of facilities, and also data from the supporters who supported the project. And in terms of the future projections, we've got reasonably good projections on terms of things like climate. The Met Office have got quite good figures. Refrigerants, which are based very much on phase down of refrigerants in the future. Emissions factors, which will change as more renewables come onto the grid. Energy predictions, some of which we're creating and some of which we're able to compare with government figures. Information on technologies. Logistics, which is something that Heriot Watt are very much involved in and Phil's going to talk about in a minute. But also looking at business and financial models, are there things that are going to change in the future in terms of the models that are applied that may change how the cold chain operates and the emissions, and looking at trends as well. And I just wanted to say thanks very much to all the people who supported the project. A lot of these organisations are already working on developing or have developed their own roadmaps to reduce emissions. So I think it's a project that's very much relevant to many of these organisations. So thank you very much. Sorry, I may have gone slightly over my time, Graham, but I'm now going to pass over to Natalia, who will talk about the other UK project, which is zero emissions cold chains. So Natalia, over to you.
Thank you very much, Judith. I'm going to try to share my screen. There we go. Hope you can see that. So good morning, everybody. I'm Natalia Falagan. I work at Cranfield University. And as Judith said, I'm going to talk about the zero emission cold chain project that is building the road to sustainable cold chain systems for resilience. So as it's been mentioned before, our cold chain is the backbone of local and global networks. However, our conventional and the current cold chains for food and are energy intensive and new refrigerants that are often global warming, have a high global warming potential. The way we deliver cold chain has a major impact for rural economic, food and drinks industries, social well-being, climate change, food security, energy security, and urban air quality too. So the food and drink industries, as Judith has said, is one of the largest manufacturing sector in the UK. It is reliant in the UK on imports, so 83% of fruit and 47% of vegetables are imported, and this links to a food security issue. And also food security is jeopardized by climate change and also global challenges such as food loss and waste. Up to date, traditional approaches to cold chain strategies have been fragmented, intervening mainly in silos, for example, looking only at cold storage or only at supermarket chiller cabinet, only to transport. However, cold chains are highly complex and they are multidimensional systems. They support the food system from harvest and slaughter to the consumption, and they are primary source of different energy demands through the food and drink cold chains, including logistics and also transport. So with SEC, with this project, what we would like is to bring together multidisciplinary UK researchers who are experts across the food cold chain sector and sustainable energy, also government and global agency, stakeholder industries, and new technology innovators, and we cannot forget the customers that go across the supply chain. Our idea is to provide a whole systems approach to redefine the cold chain architecture and therefore reaching the target of having net zero emission by 2050. The team is formed by 4 academic partners. So we have University of Birmingham with Professor Toby Peters and Dr. Sinfang Wan, who are the experts of the whole system and pathways to impact. We have in London South Bank Professor Judy Devan and Professor Graham Maidman, who are experts for engineering and technology and also cold chain for food sectors. And they are supported by Dr. Alan Foster and Dr. Tim Brown, who has experience developing business models and modeling systems. And here at Watt, we have Professor Phil Greening and Dr. Bing Yu, who is an associate professor, who are going to be looking at logistics and business models. And at Cranfield, we are working Professor Leon Terry and myself, who are experts on food and post-harvest management. We will work closely with government, global agencies, and cold chain operators in the industry who are also supporting this project. And I would like to thank them from here. So basically, we aim to develop and deliver a clear industry-led pathway to achieve this target, the UK's net zero 2050. But we also want to maintain food security and affordability for the UK consumers, and this is an economic opportunity also for the UK. What I would like to really highlight is where we have an integrated approach to basically tackle the weaknesses of our current supply chain. We are not looking at this in a fragmented way as it's been done traditionally. And this project tries to cover all the key aspects of the food supply chain, core ambitions. We will try to assess the cooling, cold chain, and energy demands and design for an energy system in order to meet the food cold chain needs. We are also developing computer models to explore new, efficient, and decarbonized food cold chains. We assess novel storage, processing, and packaging strategies to ensure food quality and also food safety. And this is all based on the post-harvest fresh produce physiology understanding. And we will identify barriers to impact and make recommendations to overcome them, and also develop innovative business and finance models. And you will hopefully be hearing from us much more, because our intention is to disseminate our results across the project. Definitely, STEC aims to provide a roadmap on how to decarbonize the food supply chain, and in order to do that, we will be drawing together all sectors and assess all the interactions. This has a national and international application and importance, and is an opportunity for the UK to have a pivotal role to play, assisting developing countries to deploy the best low emission technologies. It is also trying to tackle the climate change influence. As Toby was saying, we are not really reaching the target of 1.5 increase in the temperature. That's going to affect the cold chain, require more energy. And this project is going to be looking at how to tackle this issue, and also future challenges like other type of disruptions in the cold supply chain, and as it has been, for example, the global pandemic we are suffering. That's all on my side. For further information, you can contact any of us. So thank you very much, and over to you, Graham.
Thanks very much, Natalia and Judith. Really fantastic introduction to both projects, and they are very much complementary of each other, feeding into each other. So sounds exciting. Just a chance for one quick question, if there is anyone at all. Okay, well, there is one in the chat, Judith, for you to respond to, perhaps. I don't know if you want to talk about that. It says, it's from Simon Parker. Do you see the current technology and future technology pathways as deliverable with current policy?
Oh, that's a difficult question. I mean, obviously there is some policy that's related to technological change, such as eco-design, particularly domestic, professional, commercial, which may be driving changes. But some of the policy issues are perhaps not ones that we're dealing with so much. They're some of the partners are dealing with those, and they may be actually better at answering those questions than I would. But yeah, quite possibly without some changes in policy, I do agree that it may be challenging to get some of these technologies taken up and applied within the timeframes that are needed.
Yeah, that's fair enough, and I think we can probably touch upon this in the discussion later on, and there are some questions which we pre-prepared that sort of touch upon this. So perhaps when we do start that discussion, we could try and pick up this then. If that's okay, I'm going to move to our third speaker, and that's Alan Foster.
Excellent. So yes, as Graham wonderfully introduced me, I'm Alan Foster, and I work with Judith, and I've been working on the baseline CO2 emissions, so trying to get an idea of where we are at the moment. So Judith went through this, but I'll just go through it again. So the scope is food refrigeration. So it's any refrigeration that's gone into cooling food, basically, or keeping food cold. We're looking at the direct emissions, so the emissions of refrigerants leaking. Remember that some refrigerants, which are being outlawed, have got global warming potentials of thousands of times carbon dioxide. So small leaks can make a big difference if you've got bad refrigerants. Also, the emissions called indirect emissions, which is the energy used to power the refrigeration systems, often comes from a power station, and you get CO2 emissions from that. So we're looking at that as well. And just about all energy that goes into refrigeration is from electricity. And this is, we're looking at emissions that have been produced within the UK. So if the emission happens in the UK boundary, then we're including it. And we're looking at dates 2019, 2020, so around about where we are now, but we're not really wanting to look at things where the pandemics had an effect, a kind of realistic value now with no pandemic. So the sources of information, as I've gone through this, I found good sources for direct, tends to be from the UK greenhouse gas inventory, which is something I think we legally have to do. But also some interesting reports by SChem and Viros. For indirect, often the best are from Dukes, which is the Digest of UK Energy Statistics. Also some SChem and Viros reports, climate change agreements, and BEIS, business environmental. Graham will know how you put the acronym for that, but I've forgotten it. But their government department. And then also some other industry government reports where needed. So the cold chain sectors, as Judith mentioned, it's farm to fork. So we've split it down into agriculture and fisheries, food and drink production, cold storage. But this is not the cold storage that you get in a pub, a little cold store in a pub, or even in the supermarket. It's the main cold storage facilities, usually between production and sales. Retail, anything from a huge supermarket down to your little corner store. Food service, now that covers lots of things from takeaways, hotels, pubs, restaurants, to the catering in a staff canteen. Transport refrigeration, all forms of moving food in a refrigerated vehicle, but only the refrigerated part of it itself, not the transport part. And then finally, domestic, which is a more simple one because it's just the fridge in your house. So here are the results that we've got so far. So, and they're kind of in going left to right, following our way down the cold chain. So we start off with agriculture and fisheries, very small, 0.05 megatons of CO2 per year. Food and drink production, the reason for that, I should say, is there's not a lot of refrigeration goes on in agriculture. There's a bit in the keeping milk cold, potatoes, things like that, but generally most of agricultural emissions are in the farming itself. The refrigeration really starts happening as you get into the food and drink production. I should also say that although we're saying food, it does include beverages as well, milk, chilled drinks, etc. So you get to food and drink production, that goes up quite significantly to 0.89. Cold storage is surprisingly quite low, considering all the warehouses keeping all this food cold. A lot of that's down to, this is direct emissions, so it's only the refrigerants being leaked. And big cold stores tend to be ammonia refrigeration, which has a global warming potential of 0. So if you leak ammonia, it doesn't affect the climate. Transport refrigeration, as I said, this does cover transport anywhere from moving your potatoes from the farm to a producer all the way to last mile delivery. But most of it really is probably between production and the cold stores, and then between the cold stores and the retail. So we've got a value there, 0.69. Retail, very high, the biggest by a long way. We've got 3 megatons. Now, this is really because supermarkets have generally been very leaky. lots of leaks because lots of big lines of refrigeration, lots of sources of leaks, and they've tended to use very high global warming gases in the order of thousands of times more than carbon dioxide. Now, this has changed a lot recently. So this value of 3 is in a rapidly declining curve. So it's a bit difficult, you know, in a few years' time, it could be a lot lower. A few years earlier, it could have been a lot higher. So I wouldn't like to say exactly this value because of the rapid change. Food service is low. That's really because these are fridges not hugely different from domestic. So they're likely to have reasonably low GWP gases, and they're likely to stay in. They're not likely to leak because they're in an integral system. And then finally, domestic, which is very low. Once again, most fridges in the market are use isobutane, which has a very low global warming potential, and they're mass produced and they just generally don't leak. So that's a very low value. So if we now go to indirect emissions, so this is really proportional to the electricity used. Agriculture and fishery is still low. If I've got 2 values, it's because in the literature I've ended up getting a range. So I've put in that range. So it gives an idea of the uncertainty. If I've got 1 value, either I've only got 1 value or I've decided that that's a good value. Food and drink, high again, cold storage low. So that's following the direct quite well. Transport is now become quite high. This is because transport vehicles tend to have bad refrigerants. A lot of transport vehicles use R4A4A, which has got a global warming potential of about 4,000, and they do leak a lot because they're moving vehicles, so there's a lot of vibration, etc. Retail is high, but not as high as it is for direct. Food service, I've got a big range here, and this is a very difficult one. There's so many different organizations, from your local pub to a pub chain to catering at a company, the NHS, schools, and there's lots of different refrigerators. So anything between storage cabinets to ice makers. So it's a really difficult one to get an accurate value for. So, you know, I'm not too sure about that, but it's an important thing to investigate further. Domestic, interestingly, is very high. It's the highest value we've got. And that's because there are so many domestic refrigerators, as I think it was said, 2 billion in the world. And, you know, just every house has a fridge in the UK. So there's a lot of fridges, and it's not a particularly efficient way of cooling food. It's better, it's more efficient with all that food in a small number of cold storage facilities than spread out over lots of little fridges. So splitting down, just in case you're interested, commercial technology, looking at particular technologies, commercial is retail effectively. So half of retail direct emissions are from centralized supermarket chilled. So they're the display cabinets that your produce and your meat, etc. And as you know, your supermarket, that's most probably half of the refrigerators are those particular cabinets. So that's why. If you look then down to integral frozen 1%, once again, there's not a lot of. Integral is where the refrigeration system is built into the unit rather than the centralized system, and they're not particularly common either. Looking at domestic refrigerators, this is the energy used per annum, so it's proportional to the indirect emissions. Fridge freezers over half. This is because fridge freezers are high energy compared to, say, a chest freezer or a refrigerator, but also probably most people have a fridge freezer rather than one of the others. So there's probably more than half of them are fridge freezers as well. The conclusions, more than half of the direct emissions is from food retail. That's a significant one. And it is an area where there's probably one of the biggest efforts to reduce. So I wouldn't say that this is going to stay like that, if, you know, assuming it is actually correct at the moment. Half of that is from the chilled centralized cabinets. The majority of indirect emissions is from domestic refrigerators, and more than half of that from fridge freezers. And domestic fridges are something that have been considered as important by Europe, which is why there's these, they're the first fridges to have eco-design labeling. So that is considered a very important thing. And it's one of the highest, if not, it's pretty sure is the highest energy user in your house will be your domestic fridge, assuming you don't have a heat pump or electric heating. If you include, would you remove heating, it is. So the next step, as Judith said, is to project a baseline, and we've got figures for energy production carbon intensity, and that drops dramatically to 2050 as the grid goes renewables. Change in stock levels. So we've got a lot of the projections are done on stock models. So every year, a number of old stock gets thrown away and a new stock replaces it. And that new stock is going to be more efficient and it's going to have better refrigerants, less likely to leak. So you automatically, just as time goes on, things get better without actually doing anything. But policy also drives this. So eco-design, European eco-design regulations, often each year they push you to a better label. So that will have an effect in reducing things as well. Now, what I would say is these figures, they're not cast in stone. If you've got better information or you disagree with anything, you want to share anything, please feel free to get in contact with me, because I'd like to get better figures, and if anyone's got anything better, and maybe in a discussion we could both help each other out. Okay, thank you very much.
Thanks very much, Alan.
Oh, you're still there, brilliant.
I'm still here, just about. Yeah. And brilliant. And it's a really good introduction, setting the scene. If we don't know what our emissions are, okay, how can we do anything about them? So yeah, fantastic. And I really like the fact that you're putting it out there to, to work together with others as well. So it's great. Questions in the chat, please, if anyone. There's one from me, which perhaps you could answer in the chat, Alan. Is are we considering climate change on implications on future emissions, perhaps?
Yes. So it's not part of this work that I've presented, but we are looking at that, and we have done some preliminary looks where we've got climate change temperature projections, and we've looked at the effect of that on heat loads and COP on cold stores and domestic refrigerators.
Fantastic. And
And
there's a
that'll
question
probably
for
be
you.
in the next wonderful presentation.
Looking forward to it already. And there's a question in the chat from Simon, which if you can respond to outside of this, that we're going, and one from Tom as well.
Yeah.
So I think we're going to move on, which is Xingfang Wang, who's a lecturer from the University of Birmingham, a lecturer in cold economy. And Xingfang's going to be telling us about drivers to 2050, looking forward to 2050, and pathways for net zero for the UK. So over to you, Xingfang.
Thank you very much, Graham. Let me share my screen. Yes, so I'm just going to present more details of the projects that Toby, Judith, and Natalia has presented on ICC and ZECC. So in Birmingham, as a team, we have been working together to look at drivers for the change to 2050 and the pathways towards net zero of food cold chain in the UK. Okay, so the first stage of our work is we are working on a needs assessment framework. So the aim of this framework is to help us understand how the food cold chain sector will look like in 2050. So in this framework, we use the approach to use the whole system approach to provide a framework considering the different categories of drivers, which include environmental, social, behavior, business and financial, and also policy, technology, and infrastructure categories. So to use this framework, we are hoping to guide us to identify the sub-drivers within those categories of food cold chain demand, and then look at the past trend and also predicting the future change up to 2050. So as the first step, we look at the 7 categories of drivers at a micro level, and then we identify sub-drivers under each of the category. And then we look at the impact of each sub-driver on the food cold chain sector and different components across the food cold chain. And we then look at projections of the rate of change of each sub-driver, then calculate the scoring index of each sub-driver based on their impact and their likelihood of occurrence, which I will introduce you later on about the scoring index. And then we calculate the scoring index and then rank them to identify the most prioritized sub-drivers based on their scoring index. And then using this, we will look at projections based on their change of the food chain demand due to those different sub-drivers. So this is just to show you the framework that we are currently developing, where we look at the micro level sub-driver and more detailed sub-drivers. We identify their impact across the different cold chain categories, from industry to commercial to domestic and transport, as Ellen just presented. We also look at the impact of cold chain components, which I will show you later. And we look at the different impacts of the food cold chain from volume required to temperature setting, and then detail what are their consequences on the food cold chain from the sub-drivers, whether they will increase or decrease the cold chain demand or shift the demand across different components of cold chain. And then we explain what our assumptions are of the changes in food cold chain demand, and then calculate the scoring index, ranking them, and then identify the prioritized ones. Then look at the projections of the sub-driver on food cold chain demand and our confidence level of their impact on the food cold chain change, and then look at the final projections. So I mentioned that we categorize the impact of the sub-drivers on food cold chain across their components of the different stage of cold chain. So we look at pre-cooling, pack-out storage, food processing units, long-haul and short-haul transport, and warehouses, more local level distribution hubs, and also large retails, medium to smaller retails, catering, last mile transport to consumers, and then domestic refrigeration as well. So we look at how they would affect the cold chain demand, for example, of the volume required of cooling, the temperature setting, the number of units of refrigerators and freezers, for example, and the duration required to be in the refrigeration system. And so just to introduce you more of the methodology we are using to calculating the scoring index. So we link the impact of the sub-drivers on food cold chain with the likelihood of how likely they are going to occur in the future or at the moment. So for the impact index, we put 70% weight on the increase or decrease of refrigeration impact, and then put 30% weight on the number of linkages of the sub-driver to different components of the cold chain. I will give you an example about how we calculate the impact index later on. So basically, we have different levels of the changes in cold chain demand, from low to medium to high, and we have different level of linkages to the cold chain components, from minimum to medium to high links. And then we look at confidence level, where we look at the robustness of evidence we found from the literature, and also whether it's been consistent and great in the literature and data we collected. And so here's an example that I'm showing you how we calculate the scoring index. So this is an example of temperature change, which is one of the sub-drivers we identified in environmental category. So in this category, we first look at the impact. So we see that the impact of temperature change on cold chain demand of food supply chain is high. So we put 3. And then we put 70% weight on it, so that's 2.1. And then we look at the links from the temperature change to different components of food cold chain, from pre-cooling to logistics to consumer, as I presented. And then we identified the number of links is also high. So we put the high link here, which is scoring 3. And then we put the weight of 30% on it. So that's 0.9. So then we add these two together, which give us a total impact index, which is 3. And then we look at the likelihood of occurrence. So how likely temperature is going to change or have been changing. And that likelihood is high. So we put, we'll put 3 here. And then we calculate a scoring index from 3 multiplied 3. We got the end result, which is 9, which shows that it has a very high impact from this subdriver temperature change on food cold chain. So we did the same calculation of all the subdrivers we have identified in our framework across the 7 different categories. And you can see that we then rank them from high to low. So here are some of the subdrivers, which are key drivers that reduce cold chain demand. For example, climate and energy policy, increased food price, Brexit, and also digitalization of the food supply chain and cold chain system. And we also identified some key drivers that would increase cold chain demand up to 2050. For example, trade policy of food, GDP growth, and also for people's change in food shopping and eating habits towards more online shopping and delivery for food, and also the type of food that people prefer for the future, and also temperature change and population growth. And then there are some other subdrivers which might increase or decrease demand of food cold chain or shift the demand from one component to another. So you can see that some of the drivers will decrease the demand and some will increase, and those will show their impact of their change on food cold chain components. So for next step, we are going to look at the feedback from the stakeholders. So as you have seen that we have a list of stakeholders in our projects that we are going to host a workshop and to get their comments on the scoring index that we have calculated. And then we'll develop scenarios considering the technology, financial, behavior, and policy options towards net zero of food cold chain in the UK. And then we will test our scenarios with our industry partners and identify the barriers and provide recommendation from the whole system approach that Toby has presented in the beginning. So we look at how they meet the cooling needs, the energy options, how they meet the climate goals and commitments, and how would we use, make, store, and move and manage code across the system, and then optimize the system by reducing demand, shifting demand, improving the whole system, and aggregate demand and supply to meet the demand of food cold chain. Then we look at what would be the behavior interventions, technology options, the services that we could provide for training and skills to maintain those facilities, and what would be the policy intervention and sustainable business models to help deliver the interventions we recommend. That's from me, and thank you very much.
Thanks very much, Xing Fang, and really fantastic presentation. And I particularly liked the fact that you're joining up across all of the parts of the project, all of the different work packages, which is excellent. And again, the outreach to everyone else outside of the project to say, you know, this is what we're doing, but what do you think? I think is really good as well. So well done. If there is any questions, please can we put them into the chat? I know that Xing Fang's very happy to answer. And we've now been joined by Phil. Phil Greening, professor from Heriot in Sustainable Centre for Sustainable Logistics, has just joined us. He's had some problems getting on. So anyway, Phil, last but not least, you're going to be talking about sustainable logistics in the food cold chain. So over to you.
Excellent. Okay. Well, sorry about all the technical hiccups there, but these things happen, I guess. So I, for the last 7 or 8 years, have been involved in looking at the decarbonisation of transport. So this is a subset of that work in terms of looking at how carbon emissions can be reduced from the cold chain and taking a logistics perspective. So the starting point for this discussion really is whether or not we can use established supply chain practices to reduce the emissions from the cold chain. By established supply chain practices, I mean, can we speed up the cold chain and through that acceleration, reduce the energy input into the cold chain? The logic of thinking in this way is that the faster the supply chain moves, the less inventory we have to store in it. And as we've seen with previous presentations, it's the storage in the cold chain that produces at least a sizable proportion of the overall emissions. And the graph at the bottom here shows you the difference that you can achieve by having smaller, more frequent deliveries. The vertical axis is the amount of inventory. And as you speed up the supply chain and you have smaller, more frequent deliveries, you reduce the overall amount of inventory that you hold on average in your storage locations. Those storage locations being primarily, in our consideration at least, cold stores, warehousing, and retail stores. The other thing that you do at the same time, so a sort of an additional benefit, is that you increase forecast accuracy and reduce lead time, which also means that you carry less safety stock. And the safety stock is the inventory that you have that buffers you against uncertainty. So this is an established supply chain practice. It reduces the amount of inventory in the supply chain considerably. And the working hypothesis is that if we can do that in the cold chain, then we will reduce the amount of energy we need to deliver to the cold chain to keep things cold and refrigerated. So that's the challenge. Now, there is a trade-off associated with this, and that is whilst you reduce the amount of inventory through more frequent deliveries, you at the same time increase the number of journeys made. So instead of having a big truck full of stuff, you use perhaps 2 or 3 smaller trucks delivering 2 or 3 times to a store where you could deliver once a week. So this produces a sort of a classical trade-off, which basically, as we reduced inventory, we reduce the emissions associated with inventory, but at the same time, we increase the kilometers we have to travel. And when you aggregate those curves together, you end up defining a sweet spot, the point of minimum carbon emissions. Now, currently, we don't know where that sweet spot is. So how frequent should deliveries be? What is the benefit that can be delivered by reduced inventory? And what is the penalty in terms of increased frequency of deliveries? So this effectively becomes our research question. So can accelerating the supply chain reduce the carbon emissions from those supply chains? In this case, we're talking about cold chains. And if it can, by how much? And what is the optimum speed for the supply chain to operate at? Now, our initial work, which is quite high level, has indicated that there is likely to be some benefit from speeding up the supply chain. We have two modelling approaches that we use to simulate cold chains and supply chains generally. One is quite high level, and I'm going to talk a bit about that. And the other is extremely detailed. And it's the latter which is actually proving most beneficial for reasons I'll come on to towards the end of the presentation.
Phil, we've just got about 5 minutes in total just to finish off. So just giving you some heads up.
This is really the last slide. So
excellent.
We've built a systems dynamics model, and we've populated that with assets, warehouses, stores, trucks. The trucks are made available to the model to select. They select the most appropriate truck for the task of moving stuff from A to B through the cold chain, and they register the carbon emissions associated with the kilometres travelled, the refrigeration delivered. They add those to the refrigeration required in the stores for the volume of inventory being stored in those locations, and they total them up. Now, the big advantage of building a model like this is that it can also accommodate different transport technologies, because those technologies are changing. They're moving from diesel trucks to electric trucks. So once we've built the model, we merely change the parameters and the variables that describe the transportation. And similarly, we can do the same thing in the warehouses and the stores as new technology evolves or becomes available. And the model can be rerun, and we can see what the carbon emission reduction would be associated with different technologies. We can also put into these models the cost for each of these components. So to conclude, it is likely that we can reduce carbon emissions by accelerating the cold chains. There are many operational benefits to doing so, good business reasons for accelerating the supply chain. And a more responsive cold chain delivers better customer value and will probably produce less waste. And I finished.
Thanks very much, Phil. And that was in world record time that you introduced this subject, and fascinating. And never thought of the sweet spot as being where the research is, but it's quite obvious when you think about it, but actually getting to there is going to be challenging. So really interesting introduction. Thank you very much. So we've come to the end of the formal presentations. Feel free to continue putting into the chat questions for our speakers, but we're going to have now a panel discussion, and that panel discussion is with a few other experts and representatives from across our industry. And please, everyone who's on the panelists, the presenters, the audience, please continue to stay for this session. It's about we'll go to 12:30. So the first part is I wanted to introduce the colleagues in who are going to be on the panel. I'm just going to say their name, and then they go through all of them, then they can introduce themselves. So we've got Tom Southall from Cold Chain Federation. We've got Malcolm Harling from Williams Refrigeration, but also representing the Food Equipment Association. We've got Andrew Mullen from Beko. We've got Star Refrigeration. We've got Dermot Cotter, and we've got Jurgen Gullah from Carrier. And I think that's everyone. But I'm just going to ask 30 seconds for Tom to introduce himself, please, and then we go to the next one.
Good afternoon, everyone. I'm Tom from the Cold Chain Federation, and we're the trade association for temperature controlled logistics industry in the UK. So our members operate the cold stores and the transport refrigeration that we've heard about today. And we've got about 100 members across the country. And really net zero and net zero policy and air quality is one of our biggest policy areas. And our organisation is focused on supporting our members through the changes, and that's based on feedback from them that they see that as the greatest sort of long-term risk to operations. So we're delighted to support many of the studies that we've heard about today, as well as doing our own work through our own net zero project.
Fantastic, Tom, and great for you to join us. Then we have Andrew Mullen, please.
Yeah, I'm Andrew Mullen. I am Head of Sustainability and Quality at Beko PLC. Beko is a domestic refrigeration manufacturer. We're currently the market leader in the UK, and we are part of a group called Arçelik, which is a Turkish-based global conglomerate who have factories in Turkey, Romania, Thailand, and South Africa, amongst others, really supplying refrigeration across the world.
Okay, that's great. Thanks very much. We've now got Malcolm Harling, please.
Good afternoon, everybody. Yes, I'm here representing the FEA, which is the Food Service Equipment Association, of which we have over 180 members. We're part also of EFSEM, which is the European Federation of Catering Equipment Manufacturers. Our reason for being is really to pass on to our members technical updates, policy, etc. from Europe to manufacturers of food service equipment. I sit or I chair the refrigeration group, and our reason for being is very similar to what the group is discussing today. So delighted to be involved.
Thanks very much, Malcolm. And apologies earlier on, I called you the Food Equipment Association, not the Food Service Equipment Association. So apologies for that.
Right.
Dermot Cotter from Star Refrigeration, 30 seconds, please.
I'm actually a consultant, Star Technical Solutions, which is a business in Star. We mainly work in instant envelope and refrigeration systems for large refrigerated spaces. And I'm here and delighted to help in this project. Thank you.
Thanks very much, Dermot. And last but not least is Jurgen Gullah from Carrier, please. You're muted, Jurgen.
So good afternoon to all of you. I guess you hear me now. It's my pleasure to attend this panel debate with all of you. So I'm Jurgen Gullah from Carrier Refrigeration. Carrier is one of the leading global providers of sustainable air conditioning, heating, and refrigeration solutions. As I'm a member of the refrigeration business unit, so I'm in charge for the regulatory affairs of the commercial and transport refrigeration business of Carrier. And we have a real global expertise in providing here sustainable solutions along the cold chain from farm to fork.
Okay, fantastic. Okay, so the first question, it goes to, I'm going to ask, this is one, I think for Andrew, please. Okay, if most energy consumption emissions are from the consumer end of the cold chain, should we concentrate on reducing emissions here? And if so, what are the technical possibilities?
I think that's a really interesting question. I think one of the challenges for us as a business when we look at our own company emissions is that 80% is in scope 3, and that's with the consumer phase. So yeah, it's something that we're very focused on. I was going to start really by just talking about something we do more globally, which is I mentioned in my introduction we have a factory in South Africa, and one of the projects they have is a project whereby they supply fridges that work on solar panels to villages in Africa which are off grid. And they now have versions of that which will be solar powered during the day and will then run off power during the night. But of course, that doesn't have to be on grid power. That can be from a battery which itself is charged by a solar panel. So I suppose what we can conclude from that is that given the right environment, we can dramatically cut the energy consumption. I think when you look at the UK market, is obviously very different, and it's interesting that whilst there's very clearly a lot of emission in terms of the consumer usage phase, when you look at how the technology has evolved, and eco-design was mentioned before, if you take a fridge freezer, standard 2-door fridge freezer that was manufactured in 1995, annual energy cost for running that was about £128 a year. For that, a similar product manufactured in 2015, based on a similar tariff, the energy running cost for that product across the year was £28. So there's already been huge moves in terms of energy consumption. There is obviously more we can do. There are changes being made in compressor design. We're moving from the traditional way of manufacturing compressors to much more energy efficient ways. We're looking at different types of insulation, primarily based around bioplastics and bio-insulation rather than the way we do it at the moment. We're looking at changes in refrigerant gases. I did want to pick up on something that Alan Foster mentioned regarding refrigeration leakage, and it's true, there's very little refrigeration leakage in domestic appliances until you get to end of life, because 30% of what goes through the compressor, the recycling plant, has already had the compressor removed from it and all the gas released, because the compressor is the one valuable part of the product at end of life. The other point I would make is we are seeing, in terms of the market, and again, Alan referred to people having a fridge freezer. One of the issues is people don't have a fridge freezer anymore. They have several fridge freezers, or fridges or freezers. And the trouble is that when it comes to buy a new fridge freezer, they don't tend to get rid of the old one. We saw that. We've seen a dramatic rise in that over the last 18 months since the pandemic, where we've seen, probably relatively minor issues in the food supply chain and a massive demand as people go out to buy predominantly additional freezers to store food. And I think the trouble with the old fridge freezer is it doesn't come off the market. What it does is it gets repurposed and they keep beer or wine or something else in it, and they just don't use them efficiently. And so I think, that's one area of focus. Again, back to the technology, one of the things we're focused on is extending food life, and there's all sorts of clever stuff you can do around air circulation, about lighting in fridges to extend food life. And as we know, food waste is a huge contributor to CO2 emissions. So that's probably a good place for me to stop.
Yeah, no, it's really good. And I think that plays into what you said at the beginning, plays into a question from Suzanne, which talks about the link with the cold chain, with the existing grid, and actually how we can use renewable energy when the sun shines and the wind blows and it's low carbon. So that's really interesting. I'm going to go to the second question, if that's all right. And this I'm going to ask to Tom, and this is about, are there greater opportunities for behavioural change and demand reduction than technological improvements? Tom, what do you think?
Well, I think at the consumer end, as we just heard, I think behavioural changes in consumers are going to be the biggest driver for reducing emissions across many sectors. But to focus on, I guess, my specific area, and the area of our members, storage and transport refrigeration, I think the answer is a sort of combination of both. So I think it's easy for us to fall into the sort of habit of saying, innovation is going to be the key to reducing emissions in industrial refrigeration. But actually, I think behavioural changes can have a key part to play as well, particularly in the short term. There's lots of options for optimising refrigeration plants, for improving energy efficiency within cold storage, and operation as well as the supply chain. So improving practices around how we move a product between cold stores and vehicles, and ensuring that any heat gains into cold stores and things like that is kept at an absolute minimum. So we know there's lots to do, and that's part of our federation's drive to support members. And the benefit of those, I guess, is that they're generally lower cost, especially if they're more procedural. But I think technological improvements are going to be perhaps, certainly in the medium and long term, and it's happening already, the biggest overall driver of that kind of drive to move emissions down. And there's lots of examples of that. Talked about transport refrigeration, which is primarily a diesel powered activity at the moment. There's a real kind of signal that's moving towards more electric sort of powered sources. Of course, lower GWP refrigerants, as we've heard about, will have that innovation to bring those down as much as we can will have a real big impact, as well as things like better temperature monitoring, temperature mapping, and automation in cold stores. So I think perhaps, technological improvements are going to be some of the big game changers, but there's an awful lot of things we can do in the meantime while some of those solutions are developed to reduce emissions through behavioural changes.
Yeah, and I think it's a really good point, and I think it plays into the second part of Suzanne's question, which talks about, you know, perhaps we're trying to focus on novel technologies and rather than use what we've already got in the best way. And I think that's very much part of what we need to do is use the best technologies that we have today in an integrated way that works with the energy system and the grid. And does anyone else want to build upon this question at all? If not, we should go to the question 3, which is, do you see anything being a game changer for reducing refrigeration cold chain emissions? So that again plays into Suzanne's points and what you've just said, Tom. And I'm going to ask Dermot actually to kick this off, and maybe Malcolm, you want to come in as well.
In a way, technology, it's already there. It's 20 years of age. What you need to use is the old technology that's already available. An example, there is brand new industrial refrigeration equipment being put in, and it's 30% inefficient. And a lot of the reasons is, if you go to the marketplace, can I have a refrigeration plant? The person buying it doesn't know anything about refrigeration. He's a store manager or a truck driver, a warehouse. There's a lack of engineering ability. And everybody says the same things. Oh, we provide an energy efficient solution. We're green. But when you analyze it, it's not in use. Like one of the examples out there, there is EC fans. If you go to 90% of the sites where there are EC fans, they're actually running at fixed speed. So the technology is there. So they put in EC fans, use the buzzwords, but they're not actually implementing this technology. But the challenge also is within the refrigeration industry, you don't have the technical ability always to use this technology and how to implement it. And that is one of the real challenges, is it's the ability and the know-how and the knowledge on all sides to actually move forward. And has anybody else found that within the audience, that technology, it's there, but people just don't use it? Can everybody hear me?
I mean, maybe that's a question for Jurgen as well.
Yeah.
Jurgen, what do you think about that?
Yeah, for sure. I mean, there's potential on the side of the users. That's out of question, as Dermot mentioned already. And I mean, I would not consider that. I mean, we have one big game changer along the technologies in the cold chain that is driving the improvement and the reduction of the emissions towards a low carbon cold chain overall. I mean, it's stepwise improvements. I mean, if you look at the display cabinets, for example, that over the years, I mean, there's an improvement in the insulation technologies, there's an improvement in the air curtain technology. We have seen more and more glass doors in front of multi-deck cabinets in the supermarkets or the hypermarkets. I mean, we have seen the move to LED lighting. I mean, we have seen increased evaporating temperatures, lowering of condensing temperatures to improve the energy efficiency of the systems, and then the move towards low and ultra low GWP refrigerants or natural refrigerants in these applications. And these are step-by-step improvements that we see in the cold chain technology as well. Recent developments in the transport refrigeration sector, where we see that electrical driven refrigeration units are coming into play now instead of traditional diesel driven units, where we will need the respective infrastructure installed so that these systems can now really contribute their full benefits to the reduction of the carbon footprint of these transport refrigeration systems. So, and then also, I mean, what Tom already mentioned, if you look at the consumers, I mean, along the food cold chain, I mean, we see that there's a major contribution to food waste. from the behavior of the consumers, where there are really potential for big improvements. While if you look more at the developing nations, I mean, there the problem we see more in the cold chain itself, from farm to market, and there we need to expand the existing cold chain and then to expand with sustainable technologies to really bring the benefits of the sustainable technologies available today also to these developing countries. And Toby mentioned in his introduction already, there are some really very, very interesting lighthouse projects like this project in Bangladesh or the ACES Center in Rwanda that will help showcase really what is available in sustainable cold chain technologies, and that can help also developing countries to learn quickly from these lighthouse projects.
Thanks, Jurgen. I'd like to go on a bit now to ask the panel maybe a bit about looking at the future. Maybe this is one for you, Malcolm. What do you sort of see the cold chain of tomorrow looking like? Do you think, particularly in terms of food service, that's likely to change? Do you think some of the delivery models will change? You know, for example, more people eating out, you know, increases in restaurants, or, you know, do you see it moving perhaps more to, you know, a home delivery model where people, you know, just have food delivered to their homes? What are your thoughts on this area?
Yeah, there's no doubt that delivery is here to stay. In the food service arena, you're finding a lot of the pubs and the chain restaurants are having dedicated areas within the kitchen for delivery, and so that is not going to go away. And for that, you've got dedicated storage and cooking as well. But just coming back to the point that Jurgen made, which I would amplify, that's exactly right. But the problem that we have in the food service arena is that all refrigeration manufacturers have spent thousands on development using the best available technology that there is, whether it's foam, fans, compressors, you name it. Yet our customers really have still got the attitude of, will it fit in the gap and what's the cost? Which is extremely disappointing when all that investment has gone in. And we're looking at, as FEA, in lobbying government to go back to the old ECA scheme where there was a tax incentive for customers to purchase efficient refrigeration. And we haven't got there yet. So, but that's where we're aiming. But to come back to your point of the marketplace, yes, delivery has changed the way in which we're all eating food at the moment. I think COVID probably has had an effect on that as well, because we've been having more takeaway, and our customers in the food service arena, if you name, you know, some of the bigger brands, that whether it's a Wagamama, Pizza Express, Nando's, they're all in it. They're all in it for delivery because it's huge. It's absolutely huge, and it's not going away. And it's I suppose the difference is you'll see a guy come up on a moped or a push bike or something similar to deliver, and there's no cold storage on his van or his moped. He's got a little pouch that he keeps food hot or cold, as the case may be. So we are seeing a lot of change.
Thanks, Malcolm. Graham, are you back now?
Yes, I'm back.
I'll pass
Sorry.
back over to you if you're back.
Yeah. Apologies. It jumped out. I think we got for a couple of questions. One of the things that we often talk about is skills, and I just wondered if anyone's got any thoughts about what skills are needed to move this sector forward. And I don't know who would like to pick that one up. Perhaps Tom.
Yeah, I think clearly the faster we kind of move with innovation and things like that, then we need to make sure that the required kind of skills and training kind of meets up with that. I guess particularly at the moment, things like perhaps not refrigeration specific, but things like HGV drivers and things like that have really impacted the way the supply chain is operating at the moment. And potentially when you factor in the disruption Malcolm just talked about around COVID and changing buying habits, with a Brexit effect in there, there's a moment right now where perhaps we've got an opportunity to sort of reimagine our supply chain of the future, or work out how we move forward with the resources we've got. And I think that conversation's got to go hand in hand with the skills and training that's required. Jurgen talked about electric transport refrigeration units. Clearly, that's a big change from engineers on that type of equipment, working on diesel to electric. So we've got to make sure we've got those engineers trained up and ready to go, because that's a change that we see happening quite rapidly. That technology's gone from not really being available for operators to quite quickly being on the roads as we speak. And more orders going in. But yeah, lots more as well around handling. Probably others can talk about better than me, but handling future refrigerants. And another one I'd probably like to mention would be around IT and cybercrime, which we see as quite a big risk for many of our members within the food supply chain, is the risk of kind of cybercrime and disruption, both for those individual businesses, but for the supply chain as well, is really growing. And I think there's a bit of many of our members and businesses are not quite prepared for those kind of risks and what they need to do. So I think that's an area I think that skills could be developed as well. Yeah, but I think studies like the ones we've been talking about really help us to plan what the future cold chain is going to look like, and that means we'll be able to take a better look at, I guess, what skills will be required to fulfil that cold chain of the future.
Yeah, and I guess if we think about big data, that sort of opens up, the opportunity of big data from these facilities to reduce emissions. Fantastic, but that then plays into the cybersecurity side of things when there is access to machines electronically, then it opens up lots of opportunities for cybercrime. Anyone else want to build on the skills question at all?
If you talk about refrigeration,
okay, what about the
handling of refrigerants is key. And here, we are moving step by step away from pure non-flammable refrigerants to mildly flammable refrigerants, or partly highly flammable refrigerants like propane or propene. And this needs training. This is the key to really have skilled technicians working on these systems for installation, for maintenance, for decommissioning, end of life. That's the key. We have standards in place that help us guide these training activities, but we need to make sure that our workforce that is charged with the activities in really installing and maintaining and decommissioning these refrigeration systems are really well trained and can handle this. And the question even more into play if we look at the new applications in the developing world. In the developed world, we see, or we saw the problems during the coming into play of the current European F-gas regulation or UK F-gas regulation in the past years. Big training programs by AREA and its affiliated national associations to really ramp up these training activities. But if you look at the international context, and in particular the developing and emerging countries, there's a lot to do for the future to make sure that we can apply these sustainable technologies across the board.
Yeah, I think that's a really good point you raised there. And just a bit of a shout out to the Institute of Refrigeration's Real Alternatives program, which looks at how you use low GWP refrigerants in the best way. It's a training program in 15 languages worldwide. So a bit of a shout out. Miriam's on the call. Maybe you can put the URL into the chat. I think we've probably run out of time, and I think we should thank our 5 panelists. We would like to have had a bit more time, but maybe we can come back in 6 months, a year, and repeat this when we can hear a bit more about what's been going on the project. Sounds fantastic. And I'm going to pass over to Sophie, who I think is going to close this event. But thanks for everyone for a really good morning session, and I wish you good for the rest of the day and week. Thank you.
Great, thank you, Grim. Yes, just to close this session, I'd just like to thank everyone. Thank you for attending this great session, and for the presenters and panelists for sharing really the great insights on the challenges and opportunities when it comes to reducing emissions and trying to align with net zero moving forward, and practically what that means for different stakeholders across the value chain. So just as part of the Climate Champions, and we're just a week ahead of COP currently. So I'd like to take the time to reflect on that and maybe think about what that means for the sector and what that will represent moving forward. I think there's now all G7 countries have legally binding net zero commitments. That's more than 30% of global GDP, which will shortly translate into policies, regulations that will push more companies to have products and services that are aligned with these targets. And although there are many questions around how exactly can we deliver this within the cold chains industry and within other sectors, many organizations, and we've talked about it, are already demonstrating what they're doing to move in that direction. In the last month only, at the Race to Zero, which is a UN-backed campaign that aims to support companies on making the net zero commitments by 2050 and halving emissions by 2030, we've seen the largest number of companies joining the race. So there's now over 4,000 businesses that are part of this, and that includes also including end users such as largest retailers in the food industry, but also healthcare, pharmaceuticals, and so on. And these companies are going to have to look at the solutions out there and get onto the questions around how they use and operate their cooling systems to be able to align to their targets moving forward. So I guess just to close, accelerated progress is needed, and I think there's going to be a lot of momentum and excitement after COP to really tackle the emissions within the sector and thinking about Scope 3 emissions, which aren't easy, but many organizations are part of this campaign to try to think about it and think about these challenges collaboratively, because the solutions won't happen individually. We've talked about it. More intervention will need to happen collaboratively in the sector. And I think so there is still time to recognize these efforts, and I encourage everyone to push into this direction and think about how they can join the Race to Zero as well, or push their stakeholders within their ecosystem to join this movement to really bring those commitments and challenges into life together and push the solutions forward. So yeah, thanks again for having me and for being here. All the best, and have a good rest of your week.